1.
This is part 2 of the e-learning, the linear regression correlation. I'm just giving you a couple reminders. List 1 and list 2, whatever your independent variable is, go in list 1 and list 2, or you can use 3 and 4. We're comparing these on a line to see if they're linear. So using technology, construct a scattergram. Okay, I'm not putting those data values in, but I already have data values in. So if you go to stat, edit, there's your data values. These are not the ones you have, those are mine. And so I have them in a list. I want to make sure. If I want to look at a stat plot, I go to stat plot. Notice they're all off because when they're on, they cause problems with other things we do. So I turn it on. And I'm going to select scatter plot and make sure my x coordinates are here and my y coordinates are here. And you can pick whatever, make little things you want. And then I push graph. And likely there's some other stuff still in there. So I have solution to a word problem in here, and my scatter plot can't be seen. So I got to go up and clear some things out. And this time I want to try zoom stat, see if it'll give me an axis that fits my point. So there's my point. And they look fairly strong, positive correlation. And so if you're interpreting Pearson's correlation coefficient, which is called R, I need to have R. I don't have R yet. It looks fairly strong. So I go back to my main screen and I'll go back to stat again. And I want to calculate linear regression. List 1, list 2. If you don't have this little menu, it's list 1, comma, list 2. Key is there's no frequency list. It's just two lists together. And then you say, oh, wait a minute. Oh, there's my line of regression. I'm going to go ahead and write that down. Y equals 28.7x plus negative 137. But that does not give me R. So remember, we got to go to the catalog. It's down here. And we need to go to diagnostics and turn the diagnostics on. Turn it on, hit enter. Now you should be able to do the list again. Now I have the R value and the R squared, but we really want the R. The stronger, the closer to 1 is perfect correlation. The stronger, this is about 0.87 to 1 is strong, and then there's kind of a middle range. But that would be interpreting strong, positive, linear. We always use strong, moderate, weak, and then positive or negative. We always will have linear correlation. When you go to make your sketch, you pick your own scale, using your own paper. So, just make it accurate. Don't count every little mark. Make it rough. The thing I would like you to have accurate is the least squares regression line, which is this line that you found. That should be graphed correctly, and the best way to do it is to graph the y-intercept and then estimate the slope. You can also paste that equation in here. So mine, if you want, you can store it in y1. So if I push variables, that will store my equation in y1, or I can just type that in y1. But now I have a line. I can see the line. I can make predictions. I can push trace and see trace follows the different points, and then I can trace along my line. If you're making this by hand, remember that it always has to go through the line x bar, y bar, which is the average x and average y. If you want to know what those values are, you can do stats for list 1 and list 2. And there's the average x, and there's the average y. So if that helps you when you're plotting it by hand. So there's some other questions that go along with it. usually when you find the equation, it'll say how hot must it get. So it's going to give you one. It's going to give you the temperature, and you're going to interpret how long you ride. It might ask you another question. They're going to give you the distance. You're going to estimate with that. So that's all I'm giving you. The rest you can figure out. You can go back and watch more videos if you really want to.